Now see, entirely different thing. Joules heating, something related to electric power. So whenever a steady current is flowing through a resistance wire for some time, you can find that the resistance wire is getting heated up. It's not only resistance wire. If you take a circuit and a cell in it, and if you connect that in a circuit form, after some time you can find that the cell is also getting heated up. Now what causes this heating? That heating is due to what we call Joule's heating effect. It says that whenever a steady current is flowing through a wire of resistance R for a time t seconds, then there will be a heat energy developed found to be directly proportional to the square of the intensity of the current and directly proportional to resistance R of the wire and directly proportional to time t in seconds. That means that H directly proportional to I square RT and H is equal to I square RT because the proportionality constant is found to be 1. So this equation is called Joule's heating effect equation. According to this equation, you can calculate the heating produced when the current is flowing through a resistance for a time t seconds. Very important this is. Now from this, if I say heat energy by time, if I take it will be I square into R. Energy by time or rate of flow of energy we call it as power. So this is nothing but electric power. So electric power is now equal to I square R. Now applying Ohm's law into it, power P equal to, I am taking power as P equal to I square R can be split into I into R or will be equal to I into B. So power can also be written as, so I square R I into B, or one more equation you can write that I equal to V by R, so that V by R into B or power P equal to V square by R. So these are the equations that is for the electric power in an electric circuit. I square into R, I into V, or P equal to V square by R. Now all these three equations are equally important, but in which situation, which equation that you have to identify. A small idea I will give you. If you talk about a constant current condition, many resistors are constant current condition. That is in the case of a series combination of resistors. Then power across each resistor you can determine using I square R format. Because in that series combination, current remains straight. But in the case of parallel combination, when it comes R1, R2, R3 in parallel across a potential difference, then V remain constant. Therefore, in that case, we can take what? P equal to V square by R for determining the electric power across the resistors. And this is a common equation that current into potential difference gives electric power. Okay? And this power is measured in watt, you know that, represented by W, or kilowatt, megawatt, all these are the higher units, high values. Milliwatt, microwatt, these are all small values of power, the units of power. So you can see any type of these units along with power. Okay? Yeah? Right. Now, when we go deep into the entrance level and all, when we discuss, a point to be considered, let us suppose a kettle is there and that is used to heat water. In that case, we can see the heat energy required will be coming as V square by R into T, where T is the time. Power into time is heat energy. Then, if V is constant and heat energy is also constant, required heat energy, then you can see that T by R remain a constant. That means in such a case you can find a relation between time and resistance. That resistance directly proportional to time, a situation comes. This is a very important result to be remembered for solving problems. Then potential difference is constant, heat energy required is also constant, then there is a relation connecting time and resistance you can have. Okay? Now, another point here relating to power. In any electrical application, there will be a printed values on that instrument. That is, in the case of a bulb, if you take that bulb on which it is printed that 100 watt 220 volt, something like this is printed. And these printed values are called ratings. Ratings of the bulb or ratings of the instruments. Now, what actually this ratings refers is that if I say 100 watt 220 volt is printed on that bulb, it mentions that the bulb must be connected to 220 volt, the maximum. That means you can give a maximum voltage of 220 volt across it. If it goes a little bit higher than that, it bursts. So you can limit the voltage according to this. It's a precaution actually. Now, if you give 220 volt, the maximum possible to that bulb, it must be giving a power of 100 watt. That's the meaning. Okay. So rated values are very important for making connections. Now, another thing, if it is a 220 volt bulb and you give only 110 volt, suppose less than that, no problem, the bulb will be working, but the power output won't be 100 volt, it must be reduced. Okay. So, this ratage is very important in solving problems also. So, if a bulb is giving 100 watt, 220 volt, so this I say rated power and this I say rated voltage, then this instrument will be having a definite resistance. That resistance we can find out from this. How to find the resistance here? Is that VR square by R, where R is the resistance of the instrument, will be equal to rated power. Therefore, VR square by PR will give you the resistance of the instrument. Is a definite value. In some problems you are supposed to identify the resistance of the instrument. This is the way you can do it. And another thing you can note from this is that if these ratings are given, you can find the current maximum through that instrument, or the current capacity of the instrument can be understood from this one. For that, you know, power rating will be equal to voltage rating into current. This voltage rating, we know the power rating also know. Therefore, the current capacity or the maximum current to be allowed through the instrument will be equal to power rating by voltage rating. So, just by noting the ratings, or from the ratings we can identify four things. One, maximum voltage to be given, maximum power to be obtained, resistance of the instrument, and the current handling capacity of the instrument. That is the maximum current to be allowed through the instrument. So related to power, electric power, these are the main points to be remembered. And remember one thing, from this part